Today, I want to talk about a problem that many people don't expect at all, but it can destroy your alternator very quickly if you are not careful. One of my viewers recently contacted me and told me that the alternator in his recreational vehicle completely failed after he switched to a lithium battery. At first, even I thought, how is that even possible? But after looking into his setup, the reason became very clear, and the truth is, any vehicle can suffer the same damage if you make the same mistake. So if you are planning to upgrade from lead-acid batteries to lithium batteries, or if you already have, this video is very important for you. Please watch till the end, because I will also explain how to do it the right way, without damaging your alternator. Before we go deeper, let's start with the basics, because understanding this part is very important. What is an alternator? An alternator is a key component in your vehicle. When the engine is running, the alternator generates electrical power. In simple words, it converts mechanical energy from the engine into electrical energy. This electrical energy is used to power the vehicle systems and to recharge the battery. Now, here is an important point that many people forget. An alternator produces a lot of heat. To deal with this heat, alternators use internal cooling fans that are mounted on the rotor. The faster the alternator spins, the better the cooling effect. So speed and cooling are closely connected. Types of alternators. There are mainly two types of alternators you need to know about. The first type is the traditional alternator, mostly found in vehicles manufactured before 2011. These alternators usually provide a fixed output voltage around 14 volt. The second type is the smart alternator, which became common after 2011. These are controlled by the engine control unit. A smart alternator can change its output voltage depending on driving conditions. It may produce anything from 12.5 volt up to 15 volt. And in some situations, it can even reduce or stop charging to save fuel. Keep this difference in mind, because it becomes very important later in the video. Why alternators were designed for lead batteries. Originally, vehicle alternators were designed specifically for lead-acid batteries, and this works well for two main reasons. First, lead-acid batteries have high internal resistance. This naturally limits the charging current, so the alternator is protected from overload. Second, most alternators can only deliver their maximum rated current at higher engine speeds. This behavior matches very well with the charging characteristics of lead-acid batteries. So with lead batteries, everything stays within safe limits. Now let's talk about where the real problem starts. Unlike lead-acid batteries, lithium batteries have very low internal resistance. This means they can accept a very high charging current if it is available. And this is where things become dangerous. When a lithium battery is connected directly to an alternator, it does not naturally limit the current like a lead battery does. Instead, it keeps pulling as much current as the alternator can deliver. At high engine speed, this might not seem like a big issue at first, because the alternator is spinning fast, and its internal cooling fan is working efficiently. But at low engine speed, the situation changes completely. The alternator is still forced to deliver a high current, but now it is spinning slower, so cooling is reduced. This combination creates extreme heat, which can quickly damage the internal windings of the alternator. I want to be very clear here. I am not saying that you should never charge a lithium battery from an alternator. What I am saying is that you must do it correctly. To show how serious this problem can be, I want to talk about a test that was performed by a Victron dealership in Romania. This test clearly demonstrates what can happen when a lithium battery is charged without proper protection. To simulate a vehicle engine, the technicians used a three-phase motor powered by 230 volt. This motor was connected to a standard vehicle alternator using a belt. For the battery, they used a 300 ampere-hour lithium battery, discharged to 50% state of charge. This was done intentionally to maximize the charging current. A Victron BMV 712 battery monitor was used to accurately measure the current flowing into the battery. The first test was performed at 3,000 revolutions per minute. At this speed, the alternator delivered 78.9 ampere of current. Because the alternator was spinning fast, the internal cooling fan was working efficiently. The temperature remained stable at around 43 degrees Celsius. At this point, everything looked normal and safe. Next, the speed was reduced to 1500 revolutions per minute. This speed is already higher than the idle speed of most vehicle engines. Even at this lower speed, the alternator continued to supply a high current of 65 ampere. However, the internal cooling fan was now spinning much slower. As a result, heat could not be removed efficiently. The temperature started rising rapidly until it reached a critical level. Eventually, the internal windings of the alternator began to burn. The second phase of the test was done using a smart alternator equipped with an external regulator and a temperature sensor. When the internal temperature climbed toward 130 degrees Celsius, the smart alternator automatically reduced its output current. This self-protection prevented permanent damage. This test clearly proves one important point. A lithium battery can continue demanding high current even when the engine is running slowly, exactly when the alternator has the least cooling capacity. Now we can clearly identify the most common mistake that causes alternator failure. If you have an older vehicle with a traditional alternator, usually manufactured before 2011, and you connect a lithium battery using a split charge relay, this is essentially the same as connecting the battery directly to the alternator. In this situation, the lithium battery can pull uncontrolled current, and yes, this setup can damage your alternator, sometimes very quickly. Unfortunately, this wiring method is still very common. Some people switch to lithium batteries and plan to add proper charging equipment later. Others do not even realize that their vehicle already has a relay that automatically charges an auxiliary battery from the starter battery. This is why it is important to clearly say this. When using lithium batteries, this setup must be completely avoided. To safely charge a lithium battery from an alternator, you absolutely need a DC to DC charger. This applies to both traditional alternators and smart alternators. A DC to DC charger performs two critical functions. First, it ensures that the lithium battery is charged using the correct charging profile, which is essential for battery lifespan. Second, and just as important, it protects the alternator by limiting the charging current. The first thing you should check is the current rating of your alternator. For example, when I search for a replacement alternator for my vehicle using the license plate, I am offered multiple options. In my case, I can choose between a 150 ampere alternator and a 230 ampere alternator. As a general rule, the DC to DC charger should be sized between 30% and 50% of the alternator's maximum current capacity. So for a 150 ampere alternator, I installed a 30 ampere DC to DC charger. This is well within the safe range. In fact, I could even install two chargers in parallel and still remain within acceptable limits. I mention this because some people claim that DC to DC chargers damage alternators over time. If the system is properly sized, this fear is simply not justified. Electricity is based on calculations, not on assumptions or repeated myths. A DC to DC charger also acts as a current limiter. It only starts operating after the engine start phase is complete, so it does not add extra load during engine cranking. Another important point is that an alternator by itself is not a smart battery charger. A DC to DC charger applies a proper three-stage charging algorithm: bulk, absorption, and float, which is essential for lithium battery health. Modern vehicles, especially those meeting Euro 5 and Euro 6 standards, use controlled alternators that constantly vary their output voltage to save fuel. The DC to DC charger stabilizes this fluctuating voltage and provides a consistent charging output to the lithium battery. Switching to lithium batteries is not something you should improvise. It is much easier when designing a new system from scratch. Upgrading an existing installation requires a clear understanding of how everything works together. If done correctly, lithium batteries are extremely efficient and reliable. If done incorrectly, they can destroy components that were never designed to handle uncontrolled current. I hope this explanation helped you understand the risks and the correct solution. Thanks for watching, and feel free to leave your questions in the comments. This is Michael from Battery Hacker. See you in the next one.